Now let us see how to write the borderline structures. Suppose because many questions border line structures are given and you have to give the name of the compound. Therefore, first of all, you should know to write how to write the borderline structure. So I will show you a number of examples. So suppose this is the compound given. It's a borderline structure. What is the actual structure of this compound? See, every corner or the bent is having a carbon atom. So this structure has to be written like this. A carbon is here, and in one direction it has OH group, and in other place it has C triple bond N. On the other side also it has a C triple bond N, and there is one more bond has to be put, so which is H. So this compound can be written like this. You look at the other compound. It's a bond line structure. I have to write it, the molecular formula. See, any open end like this has CH3 group. So, two CH3 groups, they are connected to a carbon. And this carbon is connected to another carbon. And two more CH3 groups are there in this carbon. In order to satisfy the bonds, one hydrogen is here, another hydrogen is here. So this molecule is CH3, CH, CH3, CH, CH3, CH3. And another molecule, what is this molecule? See, 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. So CH3, CH2, 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 CH3. This is the structure. 8 carbons are there. The structure can be simply written as CH3, CH2 6 times, then CH3. And another molecule, OH, what is this molecule? So OH is attached to a carbon, which is attached to another carbon. This carbon is this, which is attached to another carbon, which is attached to another carbon, which is attached to a methyl group, and then to another carbon that has a methyl group, and then this has a methyl group. Now you hydrogen, adjust the hydrogen, 1, 2, 1, 2. 4 bonds are to be there. Each carbon has to have 4 bonds. 2. So the structure of this compound is OH, CH2, 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 CH, CH3, CH, CH3, CH3. This is the compound. I suppose you understand this. And let me write one more compound. So first write this carbon. Carbon on 3 directions methyl groups. 1, 2, 3, and this is another carbon. This is attached to another carbon with the 2 methyl groups. CH3, CH3. So here 2 hydrogens. So this compound is this CH3, C, CH3, CH3, CH2, C, here 1 hydrogen, CH3, CH3. This is this carbon. And one more. Number of examples can be written. Suppose you take this compound, H. OHC, aldehyde group. CH4. How to write this compound? So CHO is connected to a carbon, another carbon, another carbon, another carbon, and that carbon is attached to CHO. So now you have to write the hydrogens to satisfy the bond. So this compound can be simply written as OHC, CH2, 4 times CHO. Look at this structure, COOH, 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 OH. This can be written as COOH, C, another C, COOH, OH, C, COOH. So now hydrogens are to be filled. So the molecular formula is COOH, CH2, C, COOH, OH, CH2, COOH. Next one is, what is this? I write the compound C connected to a methyl group, then another C connected to a methyl group, then another C connected to a methyl group. So now hydrogens are to be filled so that each carbon gets 4 bonds. So this compound is this. Now this has to be linearly written. CH3, CH2, C, CH3, H, CH2, CH3. Suppose if you want to name this 1, 2, 3, 4, 5. So 3-methyl for 5 carbons pentane, 3-methyl pentane. Similarly, how will you write this compound? C, CH3, C, CH3, CH3. So here is 1 hydrogen. Here 2 hydrogens are to be put. So this molecule can be linearly written as CH3, CH, CH3, CH2, CH3. So 1, 2, 3, 4, 2-methyl butane, 2-methyl butane. Now you write the IUPAC name of, name of H3C, you have to write the IUPAC name of this. You first write the molecular formula. So CH3 connected to a carbon, this carbon. Next is another carbon. In that carbon, CH3 is attached. And the next is another carbon, which is connected to another carbon. And then a methyl group is attached. And then this is connected to another carbon, another carbon, another carbon. So this, and this, and finally a methyl group. Now you adjust the hydrogens. 1 hydrogen. So 4 hydrogens, 4 bonds are satisfied. Here is 1 hydrogen. Here 2 hydrogens. And here also 2 hydrogens. Here also 2 hydrogens. Here also 2 hydrogens. Now the molecular formula has to be simplified and to be written CH3, CH2, then CH, CH3, then CH, CH2, CH3, then CH2, 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 CH3. Now we identify the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 8 is the longest chain. So now you number so that the substituent will get the least number. 1, 2, 3, 4, 5, 6, 7, 8. So in third position, methyl group is attached. And in the fourth position, ethyl group is attached. So ethyl, methyl, alphabetical order. Therefore, 4 ethyl. Ethyl comes first. 4 ethyl. Then 3 methyl. So substituents are named. 4 ethyl and 3 methyl octane. Oct for 8. Octane. So when the compound is given in this form and you are asked to find the IUPAC name of the compound, immediately that compound has to be written in this form, and then you have to count the carbons accordingly and then name the compound. Next question is, which of the following is a alicyclic heterocyclic compound? Alicyclic heterocyclic compound. Alicyclic heterocyclic compound. What is alicyclic? The compound is cyclic. Some closed cycle is there. Alicyclic means the compound has to be aliphatic. Heterocyclic means it is a cyclic compounds with heteroatoms such as nitrogen, oxygen, something like that. That means that a compound in the ring other than carbon and hydrogen, that is heterocyclic. Now 4 compounds are given. A, O, B, C, D. You have to identify alicyclic heterocyclic compound. Now see, first, this is not a heterocyclic compound because all atoms are carbon and hydrogen. And next, you take this. This is heterocyclic compound, but it is aromatic. Alternate single and double bonds are there. Delocalization is possible. It is aromatic. So this is not the answer. And third, this is also aromatic because delocalization can take place by the involvement of the lone pairs on the oxygen, and it is also heterocyclic. But this is the correct answer because it is aliphatic and heterocyclic. Aliphatic and heterocyclic. Now you write the IUPAC name of certain compounds. I give here CH3, C, CH2, CH3, CH3, CH double bond CH2. You have to find the IUPAC name. How to find the IUPAC name? First, you find the longest chain. 1, 2, 3, 4. 1, 2, 3, 4, 5. Therefore, the longest chain is this. This chain is the longest chain. If you want to understand, you write it in a different fashion. CH3, CH2, C, CH, double bond CH2, two methyl groups attached, one here and one there. The same compound is written with the stretch of the longest chain in the horizontal. If you just bend it like this, and you can get this. Now, the preference has to be given to the double bond. So 1, 2, 3, 4, 5. So the substitutions, two methyl groups are attached in the third carbon. Therefore, it is 3, 3 dimethyl, 3, 3 dimethyl pent. 5 carbons are there. Pent 1 ene. Pent 1 ene. Similarly, you can name another compound. Let me write here. CH3 thrice. C, C, H, double bond, CH2. For understanding, you can write the full structure. C, 3 methyl groups are attached. C, H, double bond, CH2. Now, the longest chain, 1, 2, 3, 4. So the name is 3, 3 dimethyl, 3, 3 dimethyl bute 1 ene, butene, bute 1 ene. This compound appears to be a bit complicated, but it is not so. If you are clear in writing the structure, you can very easily name any compound. What is the IUPAC name of this compound? Write it elaborately. So CH3, I am writing this line connected to a carbon, then another carbon. That carbon is connected to another carbon. And also this carbon has double bond. It goes to another carbon and another carbon where a methyl group is attached. Then another carbon, then CH3. So here is one hydrogen, here one hydrogen. 1, 2, 3, 4, this is satisfied. Here CH2. Now the down ring, this is this carbon. So this is connected to one more carbon, and then that is connected to CH3. So here it is CH2. Then it is connected to CH2, 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 CH3. Now you find out the longest chain. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this is the longest chain. This chain is the longest one. So the longest chain can be linearly written so that we can find out the name easily. So I start from here, CH3, CH2, CH, CH3, then CH, double bond, C, C, and then in this, an ethyl group is attached. So we are going here. In this C also an ethyl group is attached. Then here is one hydrogen. CH, CH2, 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 CH3. So now this is the primary functional group. So this should get the least number. So it is better to start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the substitutions. In the third carbon, a methyl group is attached. In a fifth and sixth carbons, two ethyl groups are attached according to alphabetical order of the substituents. The ethyl has to be written first. Therefore, the name is 5,6 diethyl, 5,6 diethyl, and in the third position, methyl group is attached. 3-methyl, 5,6 diethyl, 3-methyl, dec. Dec means deca. Dec means 10. Dec. In the fourth position, unsaturation is there. Therefore, it is 4-ene. So therefore, the name of this compound is 5,6 diethyl, 3-methyl, dec 4-ene. And one more compound we can try. So nomenclature, you have to do plenty of exercises. You write the formula of 3-methyl, write the formula of 3-methyl penta 1,3-diene. How to write? First of all, it is penta. So write 4 carbons linearly. Sorry, 5 carbons. So 1, 2, 3. In third position, put methyl group. 1,3-diene. So first carbon and the third carbon are having the double bond. So now the hydrogens are to be adjusted. CH3, 1, 2, the hydrogen is here. 1, 2, 3, 4. This 1, 2, 3, a hydrogen is here. So the structure is CH3, CH, double bond, C, CH3, single bond, CH, double bond, CH2. So this is the structure of 3-methyl penta 1,3-diene. 3-methyl penta 1,3-diene. CH3, CH2, CH2, COO, CH2, CH3. Name this compound. You first split this into 2. Here, one part has come from the acid and another part has come from the alcohol. You take the longest chain as the acid. So this is ethyl butanoate. This is an ester. I suppose you know what is an ester. What is an ester? A carboxylic acid plus alcohol. When you remove one molecule of water, it becomes an ester. In ester, that part which comes from the alcohol becomes alkyl. If it is from methanol, methyl, ethanol, ethyl. And the other part which comes from the acid becomes O8. O8. So if you take butyl alcohol and butanoic acid and ethyl alcohol, what you are getting is ethyl butanoate. Ethyl butanoate. Ethyl butanoate. Look at this compound. CH3, CH, CH3, CH2, CH4. So this is an aldehyde. Nomenclature 1, 2, 3, 4. For the aldehyde, the name includes the carbon in the functional group also. So it is butanal, butanal, Al. If it is alcohol, butanol, OL. It is butanal. Substitution in the third carbon methyl group is attached. So it is 3-methyl butanal. 3-methyl butanal. Look at this compound. CH3, CH, CH, CH3, CH3, OH. Now you have to number. Either to number in this direction or in this direction. Primary functional group is alcohol. So the alcohol should get the least number. So 1, 2, 3, 4. So it is going to be butanol. The name is, in the third carbon methyl group is found. So 3-methyl butan for 4 carbons. All. Alcohol is found in the second carbon, 2 all. 3-methyl butanol. 3-methyl butanol. You look at the another compound, CH3, CH, CH double bond, CH, CHO, CH3, and here OH. Now look here. Aldehyde group is there. Unsaturation is there. Hydroxy group is there. According to the preferential order, aldehyde has to be given the preference. So you start from the aldehyde. 1, 2, 3, 4, 5. So it is actually an aldehyde. So 4-hydroxy. Substitution alphabetical order. 4-hydroxy. 2-methyl. 4-hydroxy, 2-methyl. 4-hydroxy 2-methyl pent for 5 carbons, pent. In the second position, unsaturation is there. Tween and aldehyde group is in the first carbon, 1L. So 4-hydroxy 2-methyl pent 2-enal or 2-en-1L. And let us do one more thing. I think with this, the time is over.